Right. So yeah, I mean, yesterday there was a from CEO of the Y Combinator. Y Combinator is basically what it is. Y Combinator is the biggest, at least as of now, it is the biggest, you know, community. Sorry, it is a PE firm basically that invests into startups. So basically, he had posted something and he did not have the right understanding of how LLMs work internally, and a senior scientist corrected him saying that, you know what, this is the reason it doesn't works is that because it is a lossy compression. This is a lossy compression. Lossy compression, it means that, you know what, when the nature is actually decoding and encoding the information, it does not loses any information. When the nature is doing that, it does not loses any information. But when we are doing it, obviously using calculus, we are losing some information, is being lost in this process of this huge amount of trillions of data being compressed and then again being presented to us in form of NLP or natural language text. So some kind of information is being lost to us, right? So gradually, first we will obviously first we will be studying around this only. Our in future, uh, like the future studies are going on, you know, how we need to basically come up with the better means so that we can just avoid maximum amount of information loss, and it should be smaller in nature, right? So the amount of intelligence that a human brain is running, in order to run the same intelligence, as of now it requires almost, you know, these GPUs require as much as energy in a day they consume that around 100 household would consume in 6 months. So that is huge amount of energy. So obviously the future is all about, you know, the algorithms that should not consume these much amount of energy, and they should be basically more intelligent, right? The next point basically, like I have already been talking about, you know, the point is that we have to understand that the magic lies in the data. The magic does not lies in the AI. AI is just a lens. AI is set of algorithms, you know, that basically they will simply uh, keep on hunting for the patterns in the data. First, we have to understand the data. All the magic lies in the data. This is the beauty of our reality, that whatever the things are connected, whatever the things we are seeing, all the data is somewhere interconnected. All the data is somewhere interconnected. And this whole thing is that you have to find the data. You have to actually find the relationship between the data. And from my personal experiences, like what I have seen, I'll just jump to a random slide just to tell you something. Anyways, I guess I forgot that slide. Anyways, I'll explain it here itself. So basically, what I have seen is the startups or the businesses that have been actually using. Yeah. Okay. All right. The startups and the businesses, you know, the businesses that have been using the AI properly, or basically they have been studying the data properly, right? They have been studying the data properly. All of them have been mostly, I shouldn't say 100%. I'll talk what the other 10% is. 90% of them are keeping ahead in the market, right? Are keeping ahead in the market. If all of the companies, especially, I mean, these FMCG companies and all of those things, they have a very specialized department, including they have all of the data. There is a neuroscience lab, you know, that is present in many of the places. It is present in IIM Ahmedabad, Department of Marketing. So what it does is basically they basically, whenever the ad is being run or whenever the banner is being designed, just imagine the amount of statistics being used. They basically they study it uh, portion by portion. That is, let's say this is the ad, and let's say they have designed some 5 to 6 ads. Then this is the color, and this is the person sitting here. This is the girl who is maybe looking at you, and then there is another ad. You know, there is a girl who is looking at the product, right? these kind of things, if you this is a common pattern, if you now you would start recollecting. So basically what they do is they go to these labs and then they collect some sample of 100, 200, 500 people, and then they see that what is the response, when what is the response in their brain activity, basically what is the response in their brain activity when they see those ads instantly, right? So this is the amount of like analytics that these big, because these big companies, these biscuits companies and all of those, they do not have, they all of uh, I mean they're not selling anything very different. All they have to sell you is in a different manner. So they are into marketing innovation. Their business is marketing innovation. We feel like their business is biscuits and all, but obviously their business is marketing innovation. Then obviously even in startups, I know two startups myself. One of them obviously uh, could not understand the importance of analysis and analytics. Basically, they could not understand the importance of analysis and analytics, you know, and ultimately they had to suffer. Whereas I also know a startup wherein they had a very dedicated team of analytics, and they were able to basically in the same region. Unfortunately, both of these startups working on similar products and in the same region, right? One working on analytics and one working. So basically, one leader understands that that what is the importance of analytics, right? If he himself has been any such through experience company, or he might have worked with such kind of people, he knows that what will give you an edge, right? And then the other person who does not understand all of these things, the leader who does not understand these things, and causing the company to suffer, right? So this is how much difference understanding the data can bring. Now obviously it is not that easy subject, like uh, today we'll be just discussing about the case studies, a lot of case studies in it, right? A lot of real data we'll be studying, what are the different kinds of data we have in this region. uh, and we will see that, yep, this we will be doing the whole the course. Basically today we will be just seeing some basic things, and then we'll keep on scratching, how to go through any advanced methodologies, the kind of patterns that are hidden, even if you see. So basically the best example is when you're talking to chat gpt, right? So chat gpt, did you ever notice that if there are no patterns in your text, that is the English literature, if there are no patterns in your English literature, this whole chat gpt would not have been working properly. you know all of these texts and characters and words are converted into numbers, and then it learns certain patterns, and then it responds to you. So I mean, it's hard to see we have been reading these characters and alphabets since childhood, but it's tough to find that there could be any such kind of relationship. Now those relationships are really complex. This is a really complex relationship. It's not that simple, like I said. But again, one thing to notice is that there are certain relationships, those are such complex that forget about human eye, human brain cannot comprehend. Means even if you are sitting with the right tools, even then you cannot comprehend. But one truth that I always believe that, and like I said, even when I was working on the new things for myself, all I had is theory. I just had a theory that okay, the data has to be connected. It cannot be that it cannot defy this nature of data, right? In most of the cases, the whole point being, it might take some time to me to crack this pattern, but there will be a pattern. There will be a pattern, and I followed the same process even now, even previously, all of the time, and most of the people are actually following this pattern. And this is the nature of the data. This is the law of the physics that holds true, that all of the data is basically all of the numbers, they will contain some kind of pattern. We'll just go to some previous examples, also just a relevant small bit of relevant history. Now this whole philosophy what I'm talking about, this stopped with the World War II, right? Now you might be saying that, no, it was US that stopped the World War II, because Hitler was killed and all of those things. So let me just cover a small example, right? Okay, right. So basically, there is a complete movie on this thing, but yeah, I mean, I'll give you more details on it. The Imitation Game, right? You should watch this wonderful movie, obviously. Now, basically, this is the real photo of Alan Turing, the father of AI. Basically, there's the Turing test also. There is a Turing Award. It's very much like the Nobel Prize in the physics. A Turing Award is very much similar to that. I mean, in the computer science world and all. So basically, what was happening? So almost, uh, Germany was attacking all of the UK and US ships, right? Those were carrying soldiers and everything and food items for those soldiers. So basically, they were about to lose the war. I mean, it was just said that, we are not winning that war. We are not winning this war in any such condition. And then, out of random, they took one step. They recollected all of the mathematicians in UK, and they said that, this the problem is that basically they had invented a machine. Basically, what was happening, they were able to, Germans had invented a machine. This machine somewhat looked like this, right? And now basically what it would do is it would actually, the messages were being sent to German ships that, this ship needs to be bombed and this ship needs to be, like, at this specific time. But these messages were not in plain German. They were actually very complex, cryptic messages, and the whole point was that this cryptology or this cryptography messages key, that is how to decode, it was changing every day. So basically, even if they were able to crack it, let's say they have some message and they are able to crack it, so tomorrow it will change, the key is going to change. So basically, it was just becoming impossible for them to, decode the messages, because they might decode some one, two, three messages, but it was changing every day, right? So basically, then Alan Turing, what he did was he actually developed a small machine, basically the first kind of electronic computer or electronic compute that would do. And basically, what he started doing, he started math, understanding the pattern. So basically, what he understood that this machine would be generating codes, right? It generates some code, but it would be generating that key via some kind of fixed algorithm, because that algorithm will not be changing. So basically, he developed a machine. So that machine would actually, in the morning, let's say if it is good morning, so they would understand that, there is some word called as good morning in that message. So then he would feed it to his machine. His machine would then find out that key, and then it would decode that message. As a result, they started decoding all those messages, and this was actually considered as one of the very huge step in basically decoding all of the German messages, and then finishing the World War II even before time, and basically the defeat of Germany, right? So this is the role of mathematics. There are even more examples. If you just go ahead and you can just see, there are more such examples, where such kind of Fourier theorems and all of those theorems were applied for decoding the complex messages. Right. So German U-boats sank approximately 2,800 to 3,000 allied merchant ships. This amount was roughly 1.5 to 1.5 million gross tons of ships. Additionally, 175 were sunk by the U-boats are basically, the German boats. And then uh, this was the kind of bomb machine, the forefather of the computers that was developed. And basically, he also developed, and surprisingly, after this, he also developed one small speaking machine to which you can speak. Yeah, it was back in 1950. Alan Turing developed this kind of small artificial machine which could talk to you. It was not, I mean, I do not have a lot of information around it, but yes, I mean, it was a kind of the first machine, kind of, that worked on the principles of artificial intelligence. Yeah. Now, right. So the whole idea was that, the idea is again simple, that, you grab the data, and after you grab the data, basically what you try to do is, you try to decode that data, you try to find out the patterns in the data, and then you try to do some forecasting. I mean, you are prepared for something that is about to happen, right? You're prepared for those things. And believe me, once you are prepared for anything that is about to happen, let it be in, I mean, in business, I mean, it is pure gold. This is pure gold, right? Now, AI basically first, artificial intelligence, modern artificial intelligence, it works on, uh, you know uh, basically a perceptron. Basically the smallest unit of AI is perceptron. Now it works on this, and Frank Rosenblatt was the guy who actually made the first perceptron. Now all of this AI thing, all of this AI madness that you are seeing is not new, it is old. And this is how one more pattern detected, right? One more pattern detected, that is around in the year 1960s. I might be wrong about the year, it is between 1950 to 1960 somewhere, right? So basically what they did is they developed one small perceptron, and then they developed a small neural network, right? This neural network was basically, uh, what it could do is it could actually differentiate between various images. It was the image classification thing. It was the image classification thing. And it was a small AI, right? And then what happened? Then happened what is happening today, that, oh, AI is going to take your jobs, right? And you can just go ahead and you can just read about it. So then the whole thing started, that AI will take away your jobs. AI is going to do this, AI is going to do that. Soon AI is going to uh, you know take do your household things soon. And all of those things, all investors money started flowing in, investors money started flowing in. And these investors money, it started flowing in into the startups and companies that just had some kind of AI or artificial intelligence name in them. And all of that started happening. This all madness continued for about 7 to 8 years or 10 years, I guess 7 to 8 years. And then after that, after 7 to 8 years, then basically people started realizing, after a few research papers were released, that there are a lot of drawbacks, that this AI, I mean, they even then they claimed that AI is going to, take over the world and all of those things. uh, you see this small ad here. Yeah, the future is here. Machine could soon walk, talk, see, write, even be aware. So this is actually a right. This photograph is generated using AI, but this whole banner is actually the right banner that I took. Basically, if you even if you are able to search it online, you will find that, people and investors and the big tech companies who want to sell their product on name of AI, they started doing this. So they were all these slogans around here, that, AI is going to do this, AI is going to, future is here, machine will soon talk, walk, and see and write, and even be aware. It will take over you, it will be your friend and whatnot, right? And then soon all of this bubble disappeared. So there is nothing new. This all has happened before, right? Only if we had historical data, we all would had known it. However, what happens is all of these waves come after a generation. Let's say it is our generation that is seeing this. Now, let's say it might happen after 60, 70 years, when we might not be there. There will be a new generation, and all of this data might be hidden under, lot of documents and lot of search, and the relevant search might not be there, that what happened 60, 70 years ago. So, okay. Now, the power of connecting dots, this is what we'll be doing throughout. This is what artificial intelligence is all about, the power of connecting dots, right? First, we'll have a look at few more examples. One example we did saw was the real example. All of these are real examples. Then we'll start with first studying some data, visualizing them, right? This is the agenda for today. This is what we want to do. Now, basically, in 1950, again, cholera breakout was there. There was a cholera breakout. Then, basically, what happened? Dr. Snow, the real one, he collected all the data and he prepared all this data like this. And then, after preparing the data, what he started noticing that basically wherever the the people near the water bodies are getting more sick, so he started noticing a pattern in it, and that pattern may not be visible by, if the data was not collected properly, right? If there was no data, there was no pattern, and then people would continue to suffer. Or else someone would notice, let's say if someone is living near a water body, then he would notice that, okay, this is what is happening. And then, I mean, it is not a well formed study. So basically, he visualized the outbreak, and he visualized in the map showing that, city districts, water source location. He identified a pattern, a significant cluster of cholera cases, and then basically he started then comparing it with other areas, and then he devised a solution to it, basically the cleaning and cleaning of the contaminated area and treating them well. So he basically prevented the outbreak of cholera. I mean, basically, back then it was not a very well treated disease. So he started doing that, right? So statistics, in fact, these numbers or these statistics play everywhere, everywhere, including in your cell phone when you're buying something, when you're booking your cab, let it be price search or anything. Just a small incident, like again on the same fundamental. Back, I share it with my family and friends sometimes. So back, I guess 4 years back, there was a CNN interview from, I'm forgetting the name, but I mean, he is the CEO of this Pink Cabs. So basically, a Delhi-based startup that raised a lot of money from Indian investors via, the Indian stock market. So he was having a interview, and I went in, and everyone was just, so he was claiming that I would never ever apply surge prices, that my prices, like Ola and Uber, they apply surge prices. That is, whenever there is some, like there is increase in demand, then basically what happens is they increase the price. So he came up with the idea that, whenever I would never do that, I would keep my prices flat, right? However, I felt that this might be a false statement, because the reason being that if there are no surge prices, if I am, let's say I am a driver, and if I'm not getting any extra money, why will I go to a place where there is more traffic congestion and everything? Why will I go to that place? I would rather sit in some place where the roads are free, and I would reach from place A to place A in place B in less amount of time. So I stated saying that this is a bad business model and this defies the rule of mathematics and everything. And as a result, including the CEO as well as his team, jumped upon me, saying that you are trying to, how do you prove that? How do you do that? I explained them the maths. I mean, that whole thing went on for like 7 8 messages. Obviously, I am not that well known person as that CEO is. CEO was basically. And then basically what happened, even MS Dhoni had invested in his startup and everything. Anyways, all of those things, people started abusing me, saying that, you don't understand business, he understands better than you. I said, okay, that is fine. And then down the line, last year the company was after that thing, after that whole episode happened, basically what happened, after 6 to 7 8 months, they declared surge pricing. And so they declared that, okay, we are going with the surge pricing. Basically, obviously, a cab company will have to go with the surge pricing, or else the business model doesn't justify. And then what happened after the surge pricing and everything, basically, I gave one statement that this whole thing is happening just to raise money. I mean, he's just giving these statements just to raise money, and I just casually commented. Basically my that comment was largely highlighted and everything. And then after that, last year the company was booked for fraud. Basically, the same, I guess, you all might know the name. The guy was basically the company, the owner was convicted of buying very like costly flats in some scheme called Camellia etc. in Noida, Gurgaon. And then basically he used all of the investors money that the people were investing in the stocks. He used all of the money to do that. So basically, I mean, these are the common things. So like I said, the data never breaks its rules. So one thing you will have to hold, that your data, if you are doing it with right analysis and everything, then obviously it will benefit you. You can build your whole startups around it. You can build everything around it. Very beneficial in marketing. The people or the companies who are running small businesses, or who are running small companies, if you are doing anything, if you're not having the proper analysis and analytics with the marketing, it's hard that you are going to succeed until unless you don't have a product that sells by itself, right? So what is the basically the whole story? This whole story is that, first there is a problem. Can complex mathematical patterns be exploited? I mean, this is okay. A path to market mastery. Can complex mathematical patterns be exploited in financial market? I guess this was again the story of Jim Simmons, basically. And again, this Jim Simmons story is again back in 1970 80s, right? So back then what he did was, the pattern finder called as Jim Simmons, he basically developed some small codes back in 1970 80s. He developed those small artificial intelligence programs, and he literally broke the market. Basically his company was called as Resonance Technologies, and he literally broke the market. Like I said, I mean, these things keep on happening. After a few years he started developing, detecting those patterns and everything. And then basically he was able to detect, like forecast the things. Now if this could happen in 1980, why cannot it happen now? Is it something? Now if you see nowadays, you would commonly see saying, hearing people that no, this is not even possible. Someone did it in 1980, and then he was forgotten. Basically again, under the papers, under the documents, he's forgotten. So but the magic of the data will always hold true. Whosoever basically spends more amount of time with the data, he is able to crack the whole thing. And application of pattern finding is just everywhere. It is everywhere. It is in medicine, it is in finance, it is in astronomy, then it is in climate and weathers, NLP, the one you are seeing right now, in criminology, right? Retail and e-commerce, manufacturing and engineering, and basically epidemiology, right? Sorry, epidemiology, right? Sorry for my pronunciation, right? So basically it is everywhere. If you see, it is just everywhere. We just need to make it right, right? uh, Traditional ways to find out patterns, and I'll be very frank with you, this is what I do day in day out. I mean, the my job is to find patterns. I apply algorithms. I sit for 12 14 hours, and I keep on finding patterns. I keep on looking at the data. I keep on looking, running through the programs. I keep on running, and numerous amount of experiments I keep on doing. I mean, I keep on doing this day in and day out, right? So like I said, traditional ways to find out the patterns. What is the basic toolkit? Obviously, if we have to find out the patterns right now, then basically what are the right ways to find out the pattern? I just built a small flow for it, and then we will follow this flow with certain examples. We'll follow these flows, right? Like I said, I mean, till now maybe artificial intelligence subject might have been presented to you that this is this complex, this is that complex, this is this is that, but it's not that. I mean, obviously it is complex. It is a investigative field. You have to investigate the data, right? And you have to find the secrets that that data is hiding. This is the whole thing, right? So obviously the first thing is data acquisition and reading. So data acquisition is very tough part. Sometimes it's very hard to convince your company that you need to buy data, or you need to actually spend money on a company that collects data for you, right? Sometimes the CEO is not that visionary, and then basically the whole company keeps on suffering. So basically, first and foremost thing, you should have data. If you do not have data, what are you going to do? You cannot do anything, basically, right? First, we should have the data. Once we have the data, the process number two is then we need to transform and clean the data. What does it mean? What does this mean, right? We do not know anything about it, but we'll soon see. But as the plain English says, transform and clean the data, it means that obviously remove the noise. Remove the noise. The data will have some noise. Yes, data will have some noise. We will just smooth that data. We'll smooth that data. And then so that data scaling and normalization. What does this means now? Scaling and normalization. Scale. We all know that scale, right? The scale we have been using. It is the same scale. But here, what it means that let's say if I am trying to measure two things, or I'm trying to find a relationship, right, between let's say uh, two different things. Let's say one thing I have is population, and I should compare it with one more thing. Let's say population of a city or population of your small area, and let's say we compare it with something. Uh, example or sales, let's say the sales of milk, right? The sales of the milk, right? Now basically sometimes what might happen, let's say if it is Mumbai city, then obviously these numbers would be so huge, right, that there might be a chance your Excel might not be even, I mean, it is not practical that your Excel cannot accommodate those numbers. But yes, I mean, sometimes some data is so huge or so small that comparing it with something else becomes very problematic. So what do we do then? So basically, in the proper ratio, let's say if it is 10, let's say if it is 10 comma 20, I can represent the same data by 1 comma 2. So advantage is that I have scaled down the data. Now I have less memory to store this data, right? Because when we go forward, we'll see that there are so many trillions of neurons that we have to use to store the data. And then basically our basically we'll have to explore our data. We will have to use various algorithms to see that what is the relationship between this data. And once we are able to find this, now this relationship finding is something complex, and this is what we are going to study with lot of examples and lot of things. Once we are able to establish the relationship, it is a hit and trial method. You will have to keep on doing it. You will have to keep on doing it. And like I said, I mean, it is not an easy job. Although I have explained you via flow, finding one pattern can be as complex as finding it in 6 months. And this is from my experience. I mean, I'm not speaking some random numbers. There was one pattern I was able to crack back a few years back. It took me 6 months to crack that. And obviously, if you are working for some organization, they will not give us 6 months to crack all of those things. And hence research is sometimes very important when done in the right way. Obviously, research is something very important, right? And then once we have the theory established, once we have the complete flow established, that okay, this is how it is, and the complete flow is there, and these are my findings, and then we can basically model and evaluate, and then we can start predicting it. Obviously, when you are working for a customer, when you have a project received and they are telling you that we want to do this, then obviously they are not going to give you 6 months of research time, right? So basically it is best that we do not overcommit, we do not false commit them. There are many things that can happen, but they may not happen in the time that you have committed to your customer, right? So basically it is best in such areas that you commit to the customer whatever you have already researched. Because obviously there are some things you might have a long research thing that you have to research on a lot of things. You have to research on theory A, theory B, theory C. This you need to find out relationship like this and like this. But then you should only commit of what you already have in your research bucket. I have seen a lot of projects failing because they thought that they have this they might be able to do it because this relevant research they might be able to do, and then it did not happen. As a result, uh, big things failed, right? So yeah, all right. Now let's try to basically, see this whole thing. I just have a small demo here so that you can see this better, and then we can actually jump to the real data. I basically collected some real data. We'll jump to Excel this time. Like I said, the whole thing being that if there is any logic, right? If there is any logic, then that logic should be we should be able to put that logic in Excel. So, I mean, if I am saying that this is logical and this logic is connected this and this way, then I should be able to put that in Excel. Python or scripting is just another way to automate that, right? It is just a way to automate that. If let's say there is something happening in Excel and then we do it using Python, so Python is a way to automate that logic. But first, logic should be present. So all of that logic, what we are going to do is all of that logic we'll be actually studying that. Most of the logic will be studying that in Excel and everything. And then we can use any scripting language, we can have any scripts to basically automate that logic. Obviously, certain things like advanced neural networks, where the calculation is dead complex, therein we will not be able to use Excel. But by then, I mean, coding in AI is not much. These big companies, even if you see the $1 billion code, $1 billion code might not be more than 3,000 or 4,000 lines, right? A good model might be just this much lines of code. However, the training, when they start training that model, when it starts accumulating knowledge, this is when the value increases. This is when any model, let's say Gemini, Chat GPT, this is when the value increases. Initially, if you go ahead and see the code of Chat GPT 2, it is very small code. It is Chat GPT 2 that is open sourced. Chat GPT 3 is not, right? So it is very small code, right? So yeah, the coding is not a overhead here. The whole key is calculation. The whole thing is calculation, right? Let me just open a small visualization. Right. So basically, let's say what is happening here. Let's say this is some thing that we have raw data, and this data is all about our what is the there is ID, there is age, there is a salary, and what is the level of the person, that age, salary, and then what is the level of the person. Then next we can go ahead with the transformed data, that what is the transformed data we have. What is the transformed data? Transformed data, what did we do in data transformation? Now, first and foremost thing, there is nothing called as, uh, see, since we are dealing with numbers, so text does not means anything. Anything, text, area, country, age, it has to be in a number. So junior, mid, senior, so it can be converted into this way. I mean, either you can convert it into 1, 2, 3, or you can convert it into junior is 1, level is mid, and this is again 0. So basically what they are doing, this is a small kind of small matrix here. Or what they have done is, what we have done is basically, uh, if it is junior, we will mark it with 1, otherwise we'll mark it with 0. You can do it this way also, or you can just have, for junior it is 1, for mid level it is 2, and for senior level it is 3. You can have it this way also, right? Both ways are having some advantages, disadvantages, that we'll keep on discussing as we go further. But here what I just did is basically I have just converted, this is called as small kind of transformation of the data. Now there are a lot of tools even available for doing this. Example, whatever I'm trying to tell you, right? This is what Tableau does, or whatever we will be seeing today. All of that is what Tableau does. Basically, Tableau is a data analysis paid tool, and we are doing all of that for free. Basically, it is a paid tool. But yeah, I mean, paid tool doesn't means that it is going to give you all of the insights automatically, right? You will have to work out on all of those things, and then it will give you the insight. The similar way, we can build all of those insights, we can have all of those things with us. And then scaling of the data, like I said, basically either I can scale the data in any of the manner, right? So scaling of the data, here we have scaling. My salary is in 5,000, my age is in 25, if you see, right? So non-comparable things, or my any of my algorithms or anything might find a difficult time to, if I have to plot age and salary in one graph, right? Then salary will be like in the 5,000 scale or 50,000 scale, and my age is just 25, 30, 45 in this scale, right? Or maybe experience, it can be anything, right? So in scaled data, what I have done in scaling of the data, there are various ways of scaling, such as, if you see, this is how this graph is actually showing you that what happens when you scale. So you can have various kind of scaling ways. One way that I'm trying to show here you is log. Is log a very complex thing? Let's find out. What is it? Visualize log. No, this is not the visualize log. Right. If you see, logarithm is just a way to scale down the data. Till now, you might have seen lot of logs, log maths. Uh, I forgot the website. It is a very good website. Logs and exponential. This is y is equal to log of x. So basically, if I enter any number here, it will just, and x is this. Where is my x value of x? Okay. Now this is my logarithm. If you see, logarithm is just a way to scale down my data. So what we are trying to do, we are just trying to scale down the data, right? And if I'm just, this is the base actually, but where is my x value here? I should be able to change my x. Okay, all right. I guess it is not showing. So basically, it is just a value to, it is just a formula to scale down the data. And this is what one way is to, I can scale down the data via ratios or anything. What works best depends on the data. I have tried all of this. Some work, I mean, depending on what we are trying to predict, right? If, by, like I said, all of these are lossy compressions. Again, we come to the point of compression and decompression, right? uh, 20 by 10 is same as 2 comma 1 in terms of ratio. In terms of ratio, no value is lost, but 20 comma 10 and 2 comma 1 are not same as magnitude. When we compare the magnitude, there is a loss of information. So whatever the thing that we want to keep, we'll have to decide that. Now don't worry about it if you are feeling confused. We will be doing all of these things. I mean, this is a common phenomena. We will be discussing this flow at least 50 times, because this is what we'll be going through the whole AI journey. So do not be confused, right? We'll be around this flow only. We'll be doing everything around this flow, right? So scaling of the data. So scaling of the data is here, right? And once the scaling of the data is there, then we try to find some relationship between these data, right? This is one relationship, that these all dots might be, connected via a straight line. This is one relationship. Or we can group them, that okay, these lines are low value data, and this is high value data, right? So we can group them together also. So it can classify as low magnitude data. Now how it should deliver the value, basically points that are grouped in orange cluster are young people, low salary data, right? Those, while in the teal green, are older people and high salary data. So basically what is happening, we are able to do it. Now even if we linear fit it, basically the red line shows the best fit between relationship. What is the relationship between age and salary? Now again, whenever someone, this is a very common trick, marketing trick, that we all have been fooled somewhere in life. Marketing trick, companies play this trick. They present you some statistics saying that, this is the statistics. So how to fool using statistics? Let's say, I'll just give you an example. Let's say if there is a room, and in that room, let's say there are all jobless people sitting, right? They don't earn anything. Their income, net income, yearly income is zero, right? Now you will, all of you working in the corporates might find this term that I'm about to tell you. Now, what happens is, they will, let's say there is one guy who enters, whose income is, let's say, $5 million, right? Now, they say that, the average income of this room is, let's say there are 10 people, and now there are some 9 people already, and the 10th people has come. So now, if the person's income is $10 million, so now they would say, this is a rich room, and the average income of each and every person is $1 million, right? And this is how they lie using statistics, right? So yeah, when we talk about statistics, I said that, the relationship between this is just limited to this sample, is just limited to this sample. you know this sample could be of, uh, let's say, one building only, and it does not applies to even one whole area. It could be of one small company of 10 people, 20 people only, right? So the more big the sample size, the better the analysis is. You can just choose to showcase a very small sample, and this is happening every now and then. I mean, a very common marketing thing, very common thing to convince people, saying that, this is happening in this area and this is the ratio. They will not even tell you that how many people on this experiment was conducted, or how many samples were included, and they will give some conclusion that, this is how the community is doing, this is what the community likes, they like this thing, they like that thing, and this is how they keep on telling us all of those things, right? So this is a common thing. Now let's jump to basically few examples. Let's jump to some real examples, and we will start with some very small and simple examples. Okay, so I have collected some data. I have some data with me. Right. So basically, let's see. I mean, now even anything you take Excel or anything, they are not less than any Tableau tool. They have almost everything that is required in the Tableau, right? Now, you also might be seeing that, questioning that, what we want to learn is LLMs, right? You want to learn how these LLMs are built and what is all this. This is the basic of everything. This is the basic of each and everything. It is LLM today, it might be LLP tomorrow, it might be MLM tomorrow, it might be anything tomorrow. The basics will remain same, right? Till the time anything technology breakthrough doesn't shifts away. Like, if let's say if it is quantum computing, AI on quantum computing, then obviously the fundamentals might change, but theme will remain the same. This is the whole theme. There might be that all of the fundamentals might shift from calculus to some other theory, but yes, till the time, I mean, we are here, I mean, next 15, 10, 15, 20, 30 years maybe, I mean, this is going to remain the same. The fundamentals are going to remain the same. and this is on these fundamentals only everything works, right? And basically these are the fundamentals how you can uh, get the best out of any model. Basically if you throw any data towards any model, you will see that it does not performs well. But if you start transforming the data, you will see that after transforming the data, the I mean you have started gaining lot of things. Now okay, here we have the data. Basically we have some retail data, right? I have some good amount of points with this thing. And what it has is basically it has some stores. It has stores A, B, C, various stores, and transactions, how many number of transactions on this specific day happened, right? What is the average ticket size on that specific day? What is the total sales happened on that specific day? What was the day, right? And was it a holiday, and was it any specific holiday for any specific store only, right? If that being the thing, then if it is holiday for everyone, then obviously it is a holiday, or else it is for festival store A, something like that, right? And then if any nearby shops were also open that day or not, right? So these are the kind, I mean, see, normally sometimes yes, you might feel that okay, these all data, if someone is doing continuously business from 5 to 7 years, they might just start, their brain might start noticing these patterns, or some people might notice it very early. But depending on how many parameters are there, let's say if I increase these parameters to 70, 80, 90, right, then obviously it is impossible for human brain to comprehend all of these parameters, right? And like I said, I mean, I have been into my family has been into retail businesses, like since almost, I do not know, 30 years. So I have seen people, I have seen many retailers suffering because they do not understand this kind of data. They are not able to shift with the data. They're still stuck with something that was 20 years old, and hence, and then there are certain businesses that have boomed, retail businesses that have boomed, right? uh, just because they were able to do the right things, they were able to choose the right platforms, from where does the traffic comes to my shop or showroom or etc., and everything, right? Now, uh, going that, okay, so here we have date and everything. Now what we are concerned with is total sales and every total sales, and then we have the date. So first and foremost thing what I would like to see is sales store wise. Now I will introduce you, although I guess every one of you knows, there is a tool that is available with you, wherein now you do not need to remember any formulas or anything. Even it might be available in the chat GPT also. I do not know if it is free or not, but at least with Gemini it's free. You can just upload it on the Google Drive. I can share these data files with you, and then you can just go ahead and play with them, right? So one way to just go ahead is, either you have to make a list of lot of formulas and everything. I can just collect them. This was traditional way how we used to do all of those things. And if you see, A, B, C, this is not a relevant data because I did not group them together, right? I did not group my data together. So let me do one thing. I will just delete this one and I will ask my AI tool itself. So basically what I want to see here is basically show me a chart of sales, total sales, store wise. Now, now just imagine when I'm playing with this data, it means I am having a series of stores, right? I'm having 4 5 stores, maybe in the same city or maybe in the same state or whatever it is, right? And then based on this, I will be deciding on my marketing strategy. Now, uh, again, when you go into business, you will see business, basically you might be managing someone's business or managing your own business. I mean, we all of us in corporate, we are bound to do that, right? Now if you are managing your own business or someone else's business, what you will notice is basically a lot of people, you will see that they will say that I take the decision on my experience and not my on my gut feeling, you know and that's the most horrible thing, right? Because Your decisions should always be data driven. A data driven decision never lies. However, a gut feeling, basically, this is the difference between, what we call properly is betting. When you are just taking some decision on your gut feeling, you are basically betting, right? You're just taking a random guess, or maybe random guess based on some proofs you might have. But then, uh, if you are doing it based on some data, you're always, mostly you are making the right decisions, right? Now, okay, chart total sales store wise, right? And here I have, it has grouped everything together. If we see, so my store A is having more business as compared to my store B, and it has grouped the total business as compared to my store C. So, okay, this is what my business is, and I can use this chart and everything. Now I can just, I want that what is my business on per day of the week, uh, versus obviously on weekends. Uh, Obviously, the business should be higher. So business on every store over days of week. Now, if you see all of this job that converting into Saturday, Sunday into zeros and ones, it is already doing it itself. Now, here it may be doing it itself, but obviously, when we feed it into some model, we will have to do it ourselves, right? It does not understand text. The store A, B, C should be store one, two, three. Everything has to be number. It is the day of the week, first day of the week. Now here it is that on Monday, right? Obviously on Saturday and Sunday, the rush was huge, right? On, let's say, what is my business when nearby shops are open or closed, right? So my total sales when nearby uh, shops are open or closed, right? And let's see this. Okay. And if you see this, when nearby shops are open, uh, my sales is extremely high, and my nearby shops are closed, my sales is down, right? Now, again, if based on gut, we had to take a decision that if my nearby shops are closed, maybe on that day, uh, I might be able to sell more because there are less number of sellers into the market. But again, the public psychology, you do not know. They might think that, most of the shops are closed. Why go for shopping on this day, right? So these kind of things, like I said, I mean, the decisions have to be very much data driven. Similarly, one analysis that comes into picture is, uh, holiday based, basically on festivals. So let's plot sales on festival versus normal days. Now, there is one more study that festivals might boost sales only in certain stores, not in all stores, right? Festivals, again, something, data that is on festivals. I mean, maybe whatever I'm selling, whatever this data belongs to, I picked up this data online. Basically, whatever I am selling on festivals, maybe people are not interested in buying that. On normal days, people are interested in buying that, or it sells only on those days, right? And so festivals, so I can also have that, is my festivals business the same across all the stores? So total sales in different stores only in festivals. Okay. So again, since total sales were already high in A, so I guess this makes sense. So yes, A is selling more as compared to B as compared to C. I mean, this is fine. right? So this is a kind of fine data that we have. Let's go to another case study, and I have few other case studies, that is a retail, and then right, similar kind of relationship I have with the ad spender basically. So basically, what is this? Again, this is going to be a similar thing, just a different data, because I mean, I guess this is a linear data only. Linear data in the sense, uh, let me tell you first what is a linear data. Let me show it to you. Although transactions, or I will show it here. Let me see. Right, that how are my ad spend and sales unit? How are my ad spend and sales unit connected together? Now, ideally, the amount of money that I spend on my ad should be directly proportional. This is what the data says. It is a straight line. This is a linear relationship. The more I spend, the more I earn. But not everything is having the same relationship. This is a very simplest relationship, linear relationship, right? And based on linear relationship, you can do the forecasting also. Let's say if you are having this dot, and if I tell you that, okay, can you predict me, if I increase my ad spend to 650, what will be actually my sales unit? Then you can say that if you are increasing it till 650, your sales unit should be around somewhere here, in this range. Like I said, AI is not about approximation. It is about probabilities. The better, if we are able to, our output should be in certain range, that okay, in between 80 to 82, right? A best trained model will be between 80 to 82, right? In the sense, I'm just giving you an example that the smaller the range, the better the output of the model is considered to be, right? So ad spend and sales unit, I mean, this is a simple one. Now, seasonality, that based on seasonality, now what we have already done here, seasonality is already done in 1 and 0 and already in scaled format. This data is already in the scaled format, right? I did not wait, because this data when I got, it was in the scaled format itself. Basically, uh, this is what scaling looks like, rather than I entering January, February, and March myself. Now you would be wondering that why it is 1 to between 1 to 0. So 1 to 0 is basically how it has been measured, that when there is a high season versus when there is a low season, right? So when there is the highest season, obviously it is marked as 1, obviously, right? And then when there is a low season, it will be marked to less than 1, let's say 0.97 and something. Now this product is something that sells throughout the year. In some like months, the seasonality is very high. In some of these months, the seasonality, so I can just find out the months where, or sales throughout the year, month wise, right? Obviously very simple one, and lots of dashboards display all of this data, and it is automatically referring to those A1 field and I field, right? And it's taking some time. Taking a lot of time basically. This data, this column needs to be grouped together, and then basically we'll have to show the sales unit. uh, Scatter chart from it is 023 to now date. X-axis should be date and aggregate. If I aggregate 1 4, so ideally I guess it is scattered around everywhere. Let's have a look at it once if it is able to do it. Now abort it. Sales month wise. Unit sales month wise. Okay. Plot it in graph. Okay, I guess we have 4 months only. So whatever we were showing in plot it in graph. Okay. So I guess yes. I mean months is not a huge problem since we have 4 months data only. So now we have that, whatever wherever the ads were running, these ads were running on which channel? These were running on search, TV, social media, or something like that, right? And average competitor spend. Now this is something very crucial, and then discount price. Now let me first, how do we come at the right discount pricing? How do we decide that what should be my right discount pricing at which my maximum sale happens, right? So then basically what I'm trying to do is basically what is the sales unit. So plot discount price, plot discount price versus sales units. Mm, mm, mm. Okay, and if we see it in the bigger screen, okay, this line is irrelevant. Now, uh, this kind of data, when you have this kind of data, if you see in this region, now if you see in this region, see in this region, this is a clustered region, right? This is a clustered region. Basically, discount price between this 90 to 95 is where most of my sales are happening because the density shows that most of my sales are actually happening here, right? I might have a lot of sales happening in this region also, but most of my sales are happening in this region, and there are less sales even happening in this region also. Now again I said this is we are just trying to discover one thing, right? This is what relationship of discount with the price is telling us. There might be other factors also influencing the same thing, right? There might be different factors. So we'll go and okay. The next is obviously we can just have if competitor spend is having any uh, effect on our sales. Let's say what is the competitor ad spend data, which is a hypothetical data which you will never get. Actually you will never get to know that what is your competitor spend data. Maybe when you are having some access of some kind of Google AdWords or AdSense, if by chance you have that kind of data, then I mean that's really good. So what is the competitor spend basically? So plot competitor spend versus sales unit as uh, so basically what it is also doing. This Gemini is automatically selecting what graph should I be seeing, right? Again, like I said, I mean, uh, this is although I had already run it and hence I knew the results. So basically, this is not very much relevant data. This is not very relevant data in the sense that we can actually discard it. The relationship with this data is not even, right? There is no linear or there is no curved relationship with the data. Now linear you have already seen what is a curved relationship will just come to it, right? And then we have some region also, that if there is any sales from the region wise, let's find out that sales region wise. So if there is any sales that is happening more in any specific region, then obviously that specific region is going to get more budget allocated, right? Okay, I guess, I mean, even that is also not much of a difference. So there is hardly some difference with the north and east, and north and south. South and east are almost similar. So obviously, then basically I should be concentrating on all of my things. Next is channel, right? Channel. That is, from which channel, if I'm running my ads, from where am I going to get the business? Where should I spend, right? And then even channel, from which channel during which time is again one relationship that should be basically studied well. So if I say and plot channel versus sales unit, channel versus sales unit, right? Channel should be aggregate. Okay, so I guess again the results are quite similar only. From search results also it is same. From social media it is somewhat better as compared to social media, and from TV also it is almost same as search itself. So basically all of my three channels are performing quite well. That means that if I have to increase my sales, I can try to boost more social media by spending more. But again, as of now, what is happening, all of my three channels are performing quite well. So based on these things, and then I can increase my uh, basically total parameters also. Seasonality is something that I should add. Lot of feedbacks I should be adding. Uh, a lot of places you go, a lot of people are calling you for the feedback, a lot of people are collecting your feedback. So this is how their business decisions are changing. This is how they are trying to sell you more things. This is how they are trying that your psychology can be understood and you could be sold more things. A very strange pattern that I also had discovered, that usually when there is a full moon, right? Now, a very strange thing, but the data exists. When there is a full moon, there is more amount of spending. And if you go and check, whenever around full moon, there are more number of selling schemes, there are more number of ads revolving everywhere. Now, again, a very strange phenomena. I mean, you might have heard it for the first time. When I read it and when I studied the data for the first time, I mean, it just blew my mind, right? So basically, I mean, not just that, I'll give you one more very strange phenomena of statistics. Basically, there are only certain days when oil containers carry the oil from the eastern countries to European countries and other countries, right? There are only selective days, and that specific days actually depend on certain weather conditions. So here, weather conditions of the eastern countries or the eastern sea will be responsible for the oil prices, right? It will be responsible for the oil prices, and this is how you can actually predict the oil price. Now you see the strange and weird relationship that exists, right? uh, okay, all right. Now let's have one more example, actually two more examples that I have to show you before we close for the day and we enjoy our final World Cup, right? And okay, temperature is something, and crop monthly. Okay, crops data, right? Crops data is something, right? And now just imagine, I mean, I have told you this relationship of weather and oil prices, weather at the eastern countries versus the oil prices. Now just imagine if the when now this has reached to me now, Even if you go ahead and search it, you will not understand, you will not find it written anywhere. But if someone like me who doesn't has any contacts or anything with the big guys is able to know it, it means someone is actually taking advantage of this data since 25 to 30 years, right? They discovered this thing 30 years ago, right? And they have been basically minting money from all of this information, right? Okay. Crop months, all right. Right. Now here again, basically, what is the whole point that we want to optimize? Let's say you are into agriculture department, and what you want to do is your job is to optimize the crop production or study that why crop production is going low. Although there is not enough data of why crop production is going low, but then someone asked you that, why in this region I feel the dip and everything and something, you have limited parameters. So let's find out, that let's find out the yield is total yield in this area happening, and there is the temperature. So let's directly, what is the relationship of first monthly yield? Let's check it out. Monthly yield, actually monthly yield, I do not know, it makes sense. Monthly yield of crop, right? That is, it means use month, use month and yield. Okay, so there is a pattern, right? Obviously, in certain months, 1 to 23, 24, this is January. This is basically now in certain months, that is, I will just make it big. Now, in certain months, that is, this month is 6th, that is June, the crop yield is very low, and then it again increases in uh, this thing, like I guess in ninth month. This is again ninth month and ninth month again. I mean, yes, but obviously anyone who is doing farming can know this data, right? Anyone who is doing this farming can know this data, right? So we'll go to more advanced thing, like what is the effect of precipitation, that is the rainfall, right, on our yield, or what is the effect of solar radiations on our crop yield. So let's find out that, find the relationship between, find plot relationship between uh, precipitation and yield. Okay, precipitation and yield can you, I guess, can be plot line graph. X is, okay, I guess more sense. This one is making more sense. So basically, lower the rainfall. If you see the rainfall is very high, it is directly affecting my crop yield, right? The yield is this way, and the best part is I should have some amount of rainfall, but the best is up to two, right? The best is actually up to one. This is the best rainfall that supports my crop yield, and then up to two also it is fine, but not as best as one. But then after that it starts decreasing. So this is actually inversely related to my precipitation, right? Let's find out with the temperature also. Plot crop yield with temperature, plot line graph. Okay, I guess line graph is not performing very well. Let me go with the scatter only. Plot scatter graph. Pass kept previous. Mhm. Okay. So yeah, high temperature is again affecting it, just like the rainfall. So a medium rainfall and the temperature near one is actually this is temperature, right? So this is basically again now, like I said, that this is a fairly simple example. Is it? Is this? I mean, is this all the data that we have seen? No, this is just a start, right? The whole idea is we want to discover the relationships, we want to create models that is able to discover even complex relationships. On top of that, we are building artificial intelligence. The aim of artificial, and this is something that you are doing manual, right? The aim of artificial intelligence is basically you will have to uh, create a model that should be able to run at least on its own for certain amount of time. Then it becomes into automation. It has already learned the patterns, and we have to make our model learn those patterns, and then it will be on its own until and unless we do not go and update it, right? Now, all of the data is not going to be in this format only, right? There is something as we go forward, there are this was simple tabular data, but yeah, most of the business processes, 60% of the business processes, even if you are following this, you should be able to find out some good pattern out of it. However, when you go through very complex patterns, let's say if you want to find out the pattern, like like one I told you with the moon and with the sales cycle, or with something like the oil and something weather or something like that, we do not even know how many relationships might be there, right? So this is one kind of relationship, and then mm, 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 just a minute. This is also one relationship, right? This is again one table, but if you try to find it out in graphs and everything, now what this is, first let me try to explain you that what this is. This is actually a real data. This is not a fake data. This is called as a karate club data. Actually, they called it as Zachary Karate Club data. Basically, what they have taken, it comes from an observation, of some, you can see that, right, right. It comes from an observation of 34 members, of a university karate club, and it was back in some 1980s or something, right? So the researcher who interacted with who, so he wanted to study the relationship. He wanted to find out just with the connection that how many friendships a person is having, what are they sharing activities and all of that, right? So basically, what we see here is there are nodes and edges. Now let me just click through that, right? There are, so basically this is what the data looks like. This is connected data. Not every data can be done this way. Not every data can be done this way, right? There, so recently these kind of graph data structures have become very popular. Now graph is something nothing new, it is old, but we are slowly, we have started to identify finding the relationship between graph. Now you see, uh, these are green ones, these are violet ones, again these are some of the patterns, and this is the data we have. This is the data we have, right? Now what does all this data means, right? uh, Basically we are trying to first find some hubs, right, that are hubs are basically highly connected members. A member, I mean, hubs are basically those members that are connected to a lot of people, something like an influencer nowadays, right? In social sense, these are connected up, something an popular person or an influential member, something like that, right? And they spread. So basically what, these are the members, if we tell something to them, the information can basically spread very quickly. Yeah, right, they're influencers, right? Basically if you have to market it, basically as of now, in Instagram it tells you that this person is having these many number of followers, but not I mean there are a lot of places, not just that, actually all of the supply chain data is present in form of graphs, right? Supply chain data, which city is a hub, which city is connected to so many places, which city should we keep our warehouses, all of this, so that it takes minimum amount of time to reach to you, right? How are they able to very precisely, very accurately predict that in how much time this item will be able to reach you, right? So basically this is the calculation that is going on, right? And then we have groups, we have groups. Then it forms, whenever we have multiple people connected together. So basically if we see, we have kind of this group we have, and we have this two groups that are present here, right? And similarly, along with these groups, there are certain communities present, right? These uh, you know when these nodes are connected to a lot of these things, so there are a lot of communities that come into picture, right? And all of the Netflix recommendation system, basically it happens on this. This is how it happens. Now what are other examples? Basically other examples, one is obviously social media, what I told you, that obviously we are studying the members. Second is transportation. Your Google map is operating on this, right? Obviously along with it, it is also operating that if someone is automatically taking some route, so it is automatically updating that route as most preferred one, right? It is having some more AI algorithms along with it. It is very much this structure is very much used in biology, right? To study the protein interactions. This is what your chemical structure looks like, isn't it? Your chemical structure, this is what it looks like, the chemical structures, right? And then we can find all of the knowledge graphs, which we'll see later on. All of the knowledge graphs that we see, this is how it looks like. The fraud rings, finding the fraud rings, money laundering, money flows, we need this kind of data. That tabular data will not help in that, right? Because now my aim has changed, I want to study something else, right? I want to study this. Is this the only data? No. Now let me tell you that there are lot many number of data structures in the sense, not the algorithmic data structures, but how we arrange the data here in this specifically for representation and for like analysis and for basically forecasting purpose, right? There are a lot of data structures. In fact, we are studying many more. Now a wonderful animation that I did show you yesterday is also a data structure of the future. This thing is a data structure of future. Why? Actually, these all are nodes and everything, connections, and on top of that, all of these shapes and everything are connected. This is something that belongs to future, right? This is called as, like I told, this is called as topology, and not I mean, this is an active area of research, right? Graphs is one thing, like this is one thing, graph patterns is one thing, tabular data is one thing. Then we have, when we go forward this time, and in last batch I did not show lot of visualizations around gradient descent and how model is learning, how model is creating its knowledge. Basically this time I want to showcase all of those visualizations, those are some very strange mountain like visualizations you will see. You will see that model is learning like, terrain like Himalayan mountains, right? It is making peaks, it is making valleys, and all of those things in 3D. Obviously our eyes can see only 3D data, so, right. Otherwise there are n dimensional data also present, but yeah. So we keep the batch limited till here itself. I'll share these files in the group with everyone. Plus, the recordings will be available. Maybe they will be available by today, tonight or today evening. So all of these recordings I'll share with all of you.